Alright, these are the notes on two-column proofs using the properties, and again, this is still section 2.6 from your textbook. So when you go to your do your homework and you get online, you need to look at section 2.6. Alright, so a two-column proof is literally two columns. The left column is statements and the right column is reasons. And in these two-column proofs, the work's kind of done for you in these particular ones. We just need to justify what the reason is for all of these steps. So the first step, it starts with this equation, and that is given. And then from there, it does something to go from step 1 to step 2. So we're going to look at it and see what changed from step 1 to step 2. What happened? Well, 18 was added to both sides, right? So if 18 is added to both sides, what if you add the same number to both property, or both sides, that is the addition property of equality. And yes, abbreviations are okay as long as they make sense. Alright, so then to go from line 2 to 3, it looks like they divided by 4. So if you do the divide by the same thing on both sides, that is the division property of equality. And since we've got to our answer of x is 12, we're done with this proof. Alright, let's look at the second one. On example 2, first they give us the equation. Well, whatever the equation is, that's just given. We can't do anything about that. So then let's see what they did to start solving. Well, it looks like they moved 3x to the left. So they subtracted 3x from both sides. So if you subtract something from both sides, that is the subtraction property of equality. Now, to go from step 2 to step 3, it looks like they moved rid of that 20. So they added 20 to both sides, except that math is really bad. 20 to both sides. You don't get 24, do you? You get what? 34. Let's adjust this. Let's not make this 20. I'll just make this 10. And that'll all work. Okay, so we're going to add 10 to both sides. So that gives us 3x equals 24. So since we added something to both sides to keep it balanced, that's the addition property of equality. And then we divided by 3, so that is the division property of equality. So basically, you're just analyzing someone's work on an equation and saying what steps they were able to do to justify their answers. Okay, so on number 3, this is a little bit longer one, but I think we can handle it. So the first step is always given. And then, took the equation around. It looks like they multiplied both sides by 3. Does everyone see where this 3 is on both sides? So when you multiply both sides of the equation by the same thing, that is the multiplication property of equality. Okay, the next step, on the left-hand side, the right doesn't change, but on the left-hand side, it appears that they distributed the 3, except I've got really bad typing, so this should be a 12 instead. So if you distribute the 3, 1/3 times 3 is just 1, so you have invisible 1x, and then 3 times 4 will give you the 12. So what that would be, the distributed property. Okay. And it looks like they subtracted x from both sides, so that's the subtraction property of equality. And then they divided by 2, the division property of equality. But now notice something over here. Notice how this x has been on the left. Well, I can't just automatically just put it on the right. But when we solve these equations and we finish it at, the x's have been on the right, you can't just automatically put it on the left like we're used to. But to finish these equations, the x has to end up on the left side of the equation for it to be officially done. So what says that we have 6 equals x, we can rewrite it as x equals 6. So think of this as an if-then statement. So if 6 equals x, then x equals 6. Well, the way we can flip it is by the symmetric property. Oops. Symmetric property. Okay, those are the algebra ones. Look at let's see the same idea with geometric ones. So it's given to you in the directions that AC equals 42, and you also have this picture to go along with it. So the first thing they said was that the measure of AB plus the measure of BC equals the whole thing, AC. So what property we learned is the left plus the right equals the whole thing with segments. Well, that would be the segment addition property. Alright, now it looks like instead of writing AB, they wrote what AB is, which is 2 times the quantity x plus 3. No, instead of writing BC, they wrote 4x. Instead of writing AC, they wrote 42. Well, if we replace something, that wasn't one of the properties I gave you, but I think we know if you replace something, that's substitution. Alright, so how they get from step 2 to 3? Well, they distributed that 2. So it's distributed property. Then we had a 2x and 4x, and then they rewrote it as 6x. This is not a property, but we do acknowledge this as a step, and we call this step combine like terms. And this is an abbreviation that I'll accept for this class, CLT, combine like terms. Okay, then let's see if they did. Oh, it looks like they subtracted 6 from both sides. So we do the same thing to both sides. That's the subtraction property of equality. And then they divided by 6 to solve. You get the division property of equality. Okay, one more this time. It's with angles. So here's our picture. And then it tells us angle MNO, that's the top one, and ONP are complementary. Well, complementary means that they add to 90. So then it said the measure of the top angle plus the measure of the bottom angle equals 90. How can they say that? Well, that is the angle addition postulate that we learned in chapter 1. And then instead of writing the measure of angle MNO, they put 3x plus 15. And instead of writing ONP, they put 2x. So if you're replacing something, that is substitution. Okay, remember, they had the 3 and the 2, and they put them together, so that's combining like terms. They subtracted 15 from both sides, so that's the subtraction property of equality. And then they divide by 5, and x is 15, so that's the division property of equality. So on your homework for this section, it's going to give you proofs that look like this. What I expect you to write down in your notes is like problem 1, and then write the reasons in order. Just fill in the blanks in order. You do not need to recopy the whole proof. Just write down what would go in the blanks for the particular problems.